1, we're trying to figure out when to use Pythagoras theorem. And basically, you need to add two sides and you find the other side. So we put a for the longer side of the rectangle and 5 for the shorter side. Then we put this in a plus b, a squared plus b squared plus c squared equals c squared.
And what's that called?
That's the formula for Pythagoras theorem.
Okay.
So 8 squared plus 5 squared equals c squared. Then I took 8 squared and made 64, and 5 squared made 25, and I can square that. Then I added that together and got 89. And for me to get that away from being squared, I had to square root it. Then the square root of 89 gives me 9.433981132. And for 1b, I changed the side we're trying to find. Then I made the longer side and made for so I did 4 squared plus b squared equals 20 squared because of a plus b squared or c squared. And that's the longer side, and that's just from the short side. And what I did was 4 squared, I made it 16, I made 20 squared for 100. Then I took 16 from this side and moved it to the other side and canceled out this. And I made b squared equals 384. Then I had to square this, change it into a normal number, and I got b is 19.59591794.
Alright, so for number 2, we were trying to find the area of a regular pentagon, and we're given the perimeter and the number of sides. So we just picked 400 for perimeter and 7 for the number of sides. So I drew a heptagon here, and so I divided it up into triangles, and then I was going to find the area of those and then multiply it by how many there were. But I needed a right triangle, so I divided it again and got 14 triangles. So we got a right angle here. So to get this, for the base of the triangle, I did 400 divided by the number of triangles, which was 14. And that was the base of one triangle. And then the center here is 360 degrees for a circle. And to get the degrees for one triangle, I did 360 divided by 14. And that gave me 25.714 about. And so we had to find the height to find the area of the triangle. So I did tan of this angle is opposite over adjacent. Tan of 25.714 equals 28.5714 over A, or the height adjacent. And then so to get that, we take this and divide it from 28.5714. And that would give us our height was 59.3292. And then to find the area of the whole thing, we did half base times height to get the triangle, and then 2 times the number of sides, because I divided it into 14 triangles, and that'll be how many triangles there are. So we plug that in, and we get 11,865.83655 for the area. So for number 3, we're trying to find a formula with missing information. So we're just going to use what we had for number 2 and take away the perimeter and the number of sides and just use P and N. So first we take what we had down here for our formula to get the area of that, which was half base times height times the number of triangles there were. And so we just canceled out the half and the 14, you got 7 times the base and height. So we're going to take away the perimeter now, it was 400, so it's just going to be P. To get the base, we did the perimeter divided by the number of triangles, which was 14, so we had P over 14. And then the height was the base divided by the tan of 25, which how we got the tan was 360 divided by 14 number of triangles for that circle angle. So that's this. And then you just simplify that by multiplying it, because it's basically P over 14 divided by tan of 360 over 14 over 1. So we can multiply and flip the second one. So we get 7 times P over 14 times P over 14 times tan of 360 over 14. So we're going to take away the number of sides now for 7n. So 7 here is n, 14 is 2n, 2n, and another 2n. So then we can simplify this down. This times that, you'll get P over 2, and then have that. And then we can simplify again, we get p squared times 4n times tan of 360 over 2n, and that's your formula for
For number 4, we're using inverse trig. We're trying to solve for an angle using inverse trig. So we have 8 for one side and 4 for this side, and we're trying to find these two angles, right? So we know this is 90 degrees because it's a right angle, so let's solve for this one first. So we're using tangent in this case because we have the adjacent and the opposite. So tan of -1, 4 over 8 is equal to 26.57, right? Then we add this number with 90, and then subtract that from 180 to get 63.43. We could also use inverse trigonometry to find this one too.
Okay, so for number 5, we did a triangular prism and we would find the surface area. So I netted it out, and then we had to split this to find the height, and then we moved it over to here, we already had hypotenuse, we already had the base, so we just had to find the height. So we put this into Pythagoras theorem, and then we put it as 4 squared plus b squared equals 6 squared. We got 16 for 4 squared and 36 for 6 squared, and then I just subtracted 16, so we got the height would be the square root of 20, which was equal to 4.472135955, and then I plugged it into 2 half BH because we had to do this twice, and then plug that in, the area would be 17.88854,382, and then I had to just find all of these squares which are equal to get 136. So, and then just had to multiply it by 3 to get 408 for all 3 of these squares. Then we plug this in. I had to multiply 17.888 by 2 because there are 2 triangles, and then plus 408 to get 443.777,08764 for the surface area. Now we move on to volume. We already have the triangle, which we found in surface area, 17.888, go on. And then we just had to multiply it by 17, because that's how long it is. And then to end up with 304.1052449.